Hello, my name is Emma C. Slick. Today, I am going to be presenting about OBJ versus GIF, a comparative analysis of expense and accessibility in cultural heritage digitization. I wanted to first start out by explaining more about myself and how this research came to be, as well as its relevance to other museum professionals. This research was undertook as part of a digitization research internship at the Dr. Samuel D. Harris National Museum of Dentistry. This presentation centers on my research conducted during my internship, focused on developing accessible digitization methods for cultural heritage institutions of all sizes. Over the past 3 years, I have worked in museums in curatorial, collections management, digitization, and research capacities, and I am eager today to share how GIF files can offer a viable digitization alternative to small to medium-sized museums. By the end of this presentation, my goals are that participants will have a greater understanding of GIF file types and their value to museum digitization efforts. Participants will evaluate the advantages of GIF files compared to current digitization methods. Participants will understand how the implementation of GIF files can benefit museum professionals and visitors. To introduce the topic, I wanted to share a little bit more about the state of 3D digitization today. Once confined to the field of industrial and medical technologies, 3D digitization has become an integral part of 21st century cultural heritage management. 3D content provides a maneuverable, recreated object. 3D content provides a faithful, often photorealistic representation of real-world objects in museum collections that enhances collections management and conservation practices and engages the public in new and creative ways by providing opportunities to zoom in and out, reorient the object, and in the case of CT scanning, to actually cross-section the object to understand its interior. 3D content is becoming more accessible both to the museum professional and to the museum visitor. Today, 3D models can be viewed on and created with mobile devices, increasing their accessibility. While 3D object digitization offers many benefits to cultural heritage institutions, there are many factors that can prohibit small to medium-sized cultural heritage institutions from taking advantage of this technology. According to a 2019 survey conducted by the major 3D viewer platform Sketchfab, respondents identify the top 3 barriers to producing more 3D content to be lack of time, lack of funding, and lack of trained staff. Similarly, a 2014 survey conducted by the Institute of Museum and Library Services found that small libraries and historical societies do not consider preservation of digitized collections a top priority. With a majority of small to medium-sized cultural institutions being unable to take advantage of the benefits of 3D digitization, an alternative digitization method is needed, along with a new file type to achieve similar benefits until the barriers can be removed. GIFs are an alternative way to create a 3D representation of an object for any size institution. It uses the same techniques but requires little to no time and expense on behalf of the institution. Utilizing images of an object from multiple different angles, a manipulatable 360-degree digital object can be created as a GIF that requires little time, training, or expense to produce, while still enhancing access to and preservation of the object for staff, scholars, and the public. Until 3D technology and file types become more accessible and standardized, the creation of 360-degree GIF files can be an inexpensive, accessible, and effective alternative for cultural heritage digitization. Moving then to discuss file formats. For this presentation, we've adopted the idea of OBJs as a cultural heritage field as one of the most prominent and most widely used file formats. So for this presentation, I follow that line in using OBJ as the model for comparison to GIF files. What are OBJ files? An OBJ file is a file format that was developed by Wavefront Technologies, which stores both geometric and textured data. OBJ files preserve textured models. This model is useful when preserving textured models, which makes it useful for documenting surface condition and conservation for collections management purposes. OBJ files are widely used, but importantly, not standardized. The OBJ file offers many different advantages, which is why OBJ files are often used as the file format of choice for many different 3D digitization projects. But there is still currently no standardized 3D file format that is universally accessible and usable in all different software programs and produced by all different 3D technologies, including laser scanning, LiDAR, and photogrammetry. OBJ files are widely used because they can be easily migrated between different softwares, as opposed to other software-specific file formats that have program-specific capacities. They can be uploaded into many different 3D model viewers, including Sketchfab, as mentioned in the earlier survey. They can be uploaded and loaded in WebGL without advanced programming. Many websites use WebGL, which is a JavaScript application programming interface that allows 3D models to be viewed on commonly accessible and commonly used browsers that require a plugin. OBJ files can be downloaded and loaded into WebGL without advanced programming required by the user and the sharer, making them accessible to researchers and the public via commonly used internet browsers. They are finally widely used. The benefit of this file format, as mentioned earlier, is that it's widely used in the cultural heritage field. According to a 2015 survey, these files are tied with PLY files for the most commonly used formats in collections management. And according to a 2019 survey, the same one conducted by Sketchfab as mentioned earlier, this file format is the most commonly used one when uploaded to their 3D model viewer online. OBJ files are widely used as a result of these benefits. They can be commonly loaded onto these online viewers. They can also be used with the WebGL. They can also be sustained over long periods of time because they are widely used. They have a vested preservation interest. Given the advantages of OBJ files, this file type has been commonly used in 3D digitization programs at cultural heritage institutions for years. The 3D Icons project saved object texture or surface color using the 3D object OBJ file format. Similarly, a National Park Service project digitized ethnographic objects to generate files that were compatible for display on websites and other 3D modeling software programs for editing purposes, including 3D OBJ files. OBJ files are directly loadable into viewers. For museums eager to share their collections with a broader audience, both in the country and out of the country across the world, OBJ files can be imported into a wide range of viewers that are accessible to anyone with an internet connection, including Adobe 3D Reviewer Blender and Sketchfab. Sketchfab also provides the opportunity to allow people to download the models for 3D printing, allowing for a new interface of connection and engagement with the collection. OBJ files, however, are not the only file formats that exist for 3D object digitization. PLY files, similar to OBJ files, often are used as an intermediary file format for conversion purposes and for their high resolution, similar to the way that TIFF files are used in archival saving procedures. Also, STL files, stereolithography files, are used to capture 3D models in a format that can be used and transferred to commercially available 3D printers. There currently exist, however, hundreds of 3D file formats, including the most common of 3DS, DAE, STP, PRT, and more. One disadvantage of 3D digitization is that so many file types exist, making it difficult to choose the right file format for your needs. Moving then on, this presentation utilizes photogrammetry, a widely used 3D model digitization creation technique, as the example, similar to the use of OBJ files as the example file format type for 3D object digitization. Photogrammetry is one example of a technique that creates 3D models in the format of an OBJ file. What is photogrammetry, however? Photogrammetry is a metric imaging method that can digitally reconstruct the geometry and texture of a real object in 3 different dimensions. The reconstruction is based on a set of photographic images covering all surfaces with enough overlap to enable easily identifiable pieces or parts of the object that can be stitched together in a photogrammetry program. It therefore involves taking multiple photographs around the object at different angles. In order to accomplish this method, images of the object are taken on at least 3 different elevations, 360 degrees around the object, at least 20 marks. This method will produce a minimum of 90 different images that can then be integrated into the program and synthesized into a point cloud of a 3-dimensional object and then a 3D digital reconstruction. Photogrammetry is one of the most widely used methods of digitizing collections because it takes advantage of DSLR cameras that are already usually in collections storage areas. According to a survey of members of Europeana Aggregators Forum and Europeana Tech Communities members, the majority of member institutions in these groups utilize photogrammetry for its benefits. It's widely used because of its versatility, as it can be conducted underwater, terrestrially, aerially, or using satellite images. Image-based modeling techniques, including photogrammetry, are preferred for monuments and architectural reconstructions, specifically those involving regular geometric shapes, low-budget projects, and those that require good, experienced workers and often have time constraints. Photogrammetry is commonly used for small to medium museums. Most literature surrounding digitization of small to medium-sized museum objects focuses on photogrammetry and structure from motion approaches, given its accessibility and cost-effectiveness in comparison to other 3D digitization techniques. Even though photogrammetry is the most accessible, it is still out of reach of most medium to size cultural heritage institutions in the field. Similar to how OBJ file types are one of hundreds of file types that exist in the field, photogrammetry is just one of hundreds of different types of 3D digitization methods that are currently being utilized. Several other 3D digitization methods include laser triangulation scanning, time-of-flight scanning, including LiDAR, and range scanning, structured light scanning, structure from motion, CT, and micro-CT scanning. All produce file types that may be proprietary. All of these methods employ different instruments and programs that produce models, some of which in proprietary file formats that are difficult to migrate and utilize, both in sharing on these 3D model viewers online, as well as also converting between different programs that may be used for mesh editing and cleaning them. Just like file formats, 3D digitization methods vary widely. There are a number of case studies in the cultural heritage field showing how photogrammetry is used in 3D digitization products. These include the 3D Icons project focused on digitizing archaeological items at the Civic Archaeological Museum in Milan, Italy. Another, for example, showing how it's used in a natural history museum, showcases how photogrammetry was used to digitize a Neanderthal talus because of how it could reconstruct the surface geometry of the bone. Therefore, photogrammetry is used in a wide variety of settings. Cultural heritage literature has documented how photogrammetry is a successful method of 3D digitization for a number of case studies, but it is still not accessible or available for many different institutions, which is why this presentation focuses on the GIF alternative. First of all, to discuss the use of digital files in museums. 3D object digitization offers benefits in conservation through virtual reconstruction and restoration of objects, and benefits in outreach, research, and accessibility of museum collection objects, especially relevant today in COVID-19. Object preservation involves how it can prevent damage occurring to objects because of excessive handling. One example including specifically removing handling with measuring historic violins by using digital measuring instead of in-person ones with calipers. For conservation purposes, digitization allows conservators to record the current surface and structural conditions of objects at a specific time point, and for rapid digitization methods that can allow real-time visualization to compare to future conservation states and stability, as well as the end point of the treatment itself, allowing a new research method. 3D digitization enhances visitor engagement of cultural heritage objects through mobile and computer-based methods. Therefore, Professionals can take measurements on objects without touching the real object, interact with the object model with visitors, and engage with a 3D model. In this example that you see on your screen, these are chess pieces that were likely made in Norway, about 1150 to 1200 AD. They currently reside in the British Museum, and this digital model exists on Sketchfab. The interesting thing and the benefit of 3D models is that the numbers that you see on your screen are attached to contextual information about each piece, about the set themselves. It's a style of digital curation that allows people who may never step foot in the British Museum to engage with and receive specific curated content. Despite these advantages, however, it's important to consider and compare both in terms of 3D digitization. For museum professionals, it can prevent contact with delicate objects. It can chart changes in objects before and after conservation, and it can showcase the effectiveness of conservation treatment and storage. For members of the public, it allows visitors to digitally manipulate 3D models. It allows them to access the collection or in place of their visit, to engage with museum collections from outside of the museum, including the Sketchfab example on the last slide. And it allows people to download the 3D model to print a physical reproduction of the object. However, there are disadvantages. It's a costly process, often involving a DSLR camera to obtain photographs for photogrammetry and handheld laser scanners for laser scanning. More recent methods employ the use of mobile cameras, but it doesn't necessarily ensure that the same product and level of accuracy will result. Nikon and Canon DSLR cameras are the most often used in the literature shown below, with prices starting at about $500 for the cheapest model. And this does not count that for other 3D digitization methods, including laser scanning, the cheapest handheld scanner can be up to $3,000. It's also a very time-intensive process requiring hours or days to replicate geometry and surface, mesh cleaning and remeshing, and color transfer. It's labor and training intensive, requiring the ability to take detailed photographs and merge, clean, and modify the specific file types for the needs of the cultural heritage institution. Therefore, it's very important to look forward and understand how they can be compared and understood within this framework of disadvantages that relate to the various advantages discussed earlier. OBJ file formats can preserve object geometry and visual surface properties, but they're not good for preserving scenes of scattered light sources. Therefore, I propose the alternative of GIF file creation. Before the advent of 3D digitization, digital video was a cost-effective alternative for creating 3D models, showing the promise of GIF files. A GIF file is an image file, and just like JPEG or PNG, a 2D file image, this is a format that can be used to save 2D images, still images. GIF file formats also allow animated images, which are not videos and do not have sound, but are rather flipbooks of multiple images that create shifts in the animation, shifts in motion that mimic an animation. They're animated images, but not rather videos, but flipbooks of still images that can be integrated similar to photogrammetry. Looking therefore at the GIF file creation pipeline. The GIF file creation involves using software programs that convert images and videos into a GIF animation. MeshLab software is used as the example for comparison to GIF creation software. MeshLab is an open source tool used to map texture and color information onto a high-resolution 3D model. It's free and widely available software that is often used by cultural heritage professionals. It's used to merge, clean, and modify. These three programs, however, for GIF file creation show how these same programs mimic the benefits of 3D OBJ file models. GIF Brewery by GIFcat is a free GIF file creation program that allows the creator to create GIF files in real time and allows editing and cropping of the resulting GIF. This program allows the user to use an existing video to make a GIF, to stitch images and videos together to create the final product, or to record independently on a smartphone, similar to the use of mobile devices for photogrammetry. Institutions that do not have a DSLR camera can therefore take advantage of this program that automatically optimizes frame count and frame delay to ensure a beneficial video. Photoscape is the only one of the three that's available for both Mac and Windows processing systems. The program allows the user to choose specific photos and then stitch them together into a GIF, and then adjust the display time for each image. It's very useful because one image or one view or one angle of the object could be especially important. Users can then edit, crop, merge, touch up, or edit the GIF just the same as MeshLab. Giphy, finally, is the only online GIF software program. GIFs can be created by editing and copying video URLs into the browser. Once the video is uploaded, the tool allows the individual to easily adjust the duration and start time using the slide bar. Also similar to embedding preservation metadata information into OBJ files, just like the chess pieces that have integrated digital curation, this program allows users to enter accession numbers as well as contextual information about the object directly into the GIF, mimicking those same benefits. So for the use of GIFs in museum, for museum professionals, GIFs are less expensive to create GIF file creation softwares because they're often free and require little to no special training. GIF files are small, lossless, and transparent, similar to archival level qualities, making them archival quality and easily to add to object catalogs, especially collections management softwares. For members of the public, GIF files can be created and sent via mobile devices and smartphones. GIF files can be embedded in exhibits with QR codes, offering an inexpensive gallery alternative. Users can even create their own GIF files. If, like in the previous video, they're able to fully move around the object and gain an impression of all different angles. GIF file creations can also, as I said before, be an exhibit activity, promoting close-looking skills that one might gain by interacting with a 3D OBJ model, but in this case could gain by actually making their own. So for the advantages of GIF files, archival quality is one big benefit. They're lossless and transparent, similar to TIFF files. The small file types of GIF files allows attachment to museum catalogs with JPEG file formats. They therefore, because of their shareability, as we see in modern society with the popularity of GIFs, they combine the benefits of JPEG, PNG, and TIFF. One other benefit is seen on this screen with Titian's Venus in the Mirror. This example comes from Multispectral GIF Playtime, the link at the bottom of the screen, and showcases how cultural heritage institutions can share spectral data, in this case X-ray data, specific to an image with the public. In this case, they're sharing examples about an X-ray image underneath, revealing that Titian actually completely shifted his canvas when he was creating it to restart, something that the public might not engage with if they can't see it directly on top of each other in a GIF file. There are disadvantages, however. GIF files are restricted in terms of their color spectrum. GIFs are 8-bit files and restricted to 256 colors, hence the animation on the right of the screen. GIF files do not overcome the problems related to this color, but they overcome the problems related to reflectivity from laser scanners and large file formats. Color sampling often poses a problem because 3D scanners are designed for geometric acquisition as opposed to color. So sampling only the apparent color of the surface and not its reflective property. Photogrammetry improves on this, but it doesn't necessarily achieve the same benefits. These two documents that you're going to see on your screen will be shared with you as resources related to the factors implicated in GIF file benefits for cultural heritage institutions. Finally, moving on to the end of the presentation. The COVID-19 pandemic has dramatically shifted the nature of access in museums. For cultural institutions to remain sustainable, a shift from solely physical access to a blended physical, digital, and virtual environment needs to occur, starting with collections. Problems of digital access for small to medium-sized museums indicate that there is a struggle to share the collection, given the cost, time, and training restraints. Because GIF files offer many different benefits, by providing a sustainable file type with a cost and effective method of digitization, they therefore offer a high-quality alternative for different cultural heritage institutions, for scholarly reference and the ability to create an essentially 3D object model with using isolated 2D frames. By harnessing a technology utilized since the 1980s, my proposal focuses on the sustainability of the digitization method for any cultural repository that may not be able to adopt and utilize more cost, time, and expertise prohibitive 3D digitization strategies. What you see at the left of your screen is the National Gallery of Art's Fashioning a Nation exhibition, available on Google Arts and Culture. Many museums are moving in this direction of creating a more accessible collection for a public that may never even enter museum doors. It's important to consider ways that GIF could be implicated in that model and advancement of 3D object digitization, similar to what's seen on Google Arts and Culture. Thank you for watching my presentation and engaging with the topic of accessible object digitization in cultural heritage settings. If you would like to continue the conversation, please feel free to reach out to me at my contact information on the screen below. As well, please feel free to tune in for my live question and answer session held on Tuesday, November 17th from 2:30 p.m. to 3 o'clock p.m. Eastern Standard Time, USA and Canada. Here are my references. Thank you so much for tuning in, and I look forward to seeing you at the digital presentation question and answer session.